although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder.
A permanent lunar base is something that we've wanted to do for a really long time. With Apollo, we were able to learn a lot, but we're going to get a lot more scientific understanding of the moon if we have a permanent lunar base. And so we need to be able to return to the same place more than once, which is why we need lunar landing pads. It's very expensive to launch things to the moon. So we are not planning to bring any construction materials to the moon. We want to use that really fine powdered material, that lunar soil, or lunar regolith is what we call it, as our building material. And so the process that we've come up with is to take that material and to melt it to make a crystalline ceramic. And so we want to use that as our building material with our 3D printers at Icon.
For this project, we need to know about the regolith because that is our raw material for construction. Every teaspoon of lunar soil you pick up is going to be different from the next in several ways. It might be different in its calcium content. It might be different in how much hydrogen it contains. So one of the products that we need to deliver is a routine for taking the compositional and mineralogical analysis of every scoop of lunar regolith that goes into the printer. And we're working closely with Icon Technologies to do that using electron microscopy. And to do this on the moon is going to require getting it to work at very cold temperatures in a vacuum.
So we really do see the moon as almost a training ground for our kind of long-term future on Mars. But we learn a lot about what it's going to take to build these self-sufficient bases a lot closer to home when we do this on the moon, so that when we're much further away on Mars, we'll kind of know the playbook.